guys, today we're going to talk about the first law of thermodynamics with the equation delta E equals Q plus W. Let's start off with delta E. Delta E is basically the sum of all of the internal energy, so just remember it's all the internal energy. That means kinetic and potential energy. Kinetic being the energy of movement, potential being, the energy that's in, let's say, chemical bonds or, or things like that. And Q and W, Q is heat, W is work. So the important thing to note here is that Q and W are path functions, whereas delta E is a state function. So basically what that means is that you can have, let's say, lighting a fire, or have, the energy that a fire creates versus the energy that you have on a stove that's boiling water. Let's say those energies, the delta E for both of those is equal to 15 kilojoules of energy. So they can have the same internal energy, but the stove is going to have a different proportion of heat and work than just the fire would have. The fire would be pure heat. So for a fire, we're going to have that delta E is going to be equal to Q because W is going to be 0. It's not doing anything. It's not, boiling anything. It's not moving anything else. It's just being released as heat. So for a stove, we're going to have delta E being equal to Q and work because it's doing some work on something else. Let's say it's, it's boiling water. So delta E is going to be, some of it's going to be released as heat. So let's say it's 9 kilojoules of heat, and some of it's going to be work, and that's going to be the rest of it. So that's going to be 6 kilojoules. So basically, if you have two internal energies that are the same, but they can do different things depending on the path that they take. So Q and W are path functions, and they can take different paths to define different chemical reactions. Thanks, guys. Bye.